So yeah guys, this is the session 3. This is Vikas, your mathematics teacher. As you guys know, we are already covering up our chapter first from our syllabus, and that is what? That is number system. So this is the final session that we are going to be holding today. In this, we are going to learn the remaining concept that this chapter has to offer, and we are going to use some basic concepts also that we have already learned regarding this chapter. And keep in mind, with this being your last video on the basis of a chapter 1, so this will be the final video, and in which we will be covering up the remaining chapter. So I want you guys to pay your full attention to this video and note each and everything down, because there won't be any other videos apart from this based on this chapter apart from this video here. So let's just start with this, and before we get to the point, let's just recall everything that we have learned up till now. So you guys remember, we had understood number system in our first session, then we understood the various types of number systems, where we understood our natural numbers, where we understood our whole numbers, our rationals, irrationals, and we understood our integers, right? Then we understood what was the difference between our rationals and irrationals, specifically on the basis of their representations, right? Then we had understood regarding what there was on the basis of the decimal expansions also, right? We had understood that rational numbers had either a terminating expansion or a non-terminating expansion, but it was what? It was repeating one, right? You guys can recall this, right? 0.333 bar, or you can say 0.3 bar, 0.11111, or you can say 0.1 bar. So these were the things that had been discussed in our earlier class. So we are going to pick from there. You guys already remember we had converted this into the form of P by Q. So till our last session, we have just covered up each and everything up till our rational numbers. Now in this session, we are going to learn what irrationals are. You guys already know what they are, but we are going to learn about their decimal expansions, how we are going to find out irrationals between rationals, or even irrationals between irrationals also. But specifically, we are going to find out irrationals between given rationals. There can be how many irrationals between rationals? You will be finding that out. You guys remember we had found out rationals between rationals, right? You guys remember that we had found out various rational numbers between two given rationals. Like if I wanted to find out any rational between these two, I had two methods here. First one was of average, and next one was keeping the denominator same. Then multiplying and dividing with the same common value on the both sides, right? You guys remember we had done like that. So we will be using those, but here we are going to find out our irrationals. So before we get to the point there, that means before we find out our irrationals, I want you guys to understand what actually is the decimal expansion. So everything here depends upon the decimal expansion of irrational numbers. Then we are going to learn how and what are the operations that we can apply on rationals and irrationals. Basically every operation that can be applied on our real numbers. Understood? Then we are going to shift towards our exponents in powers, some concepts there. Then we will be finishing up with our chapter, and that will be it. So before we jump to it, I just want to confirm this question here. We had discussed this one, and I think I might have told you something different regarding this. So I just want you guys to just look at this question here first. First understand this, then we'll jump towards what we have to learn today. So this was the question. It was what? I think I might have read this wrong yesterday. So it was this: every point on the number line is in the form of square root m, where m is natural number. So remember this cannot be happening, because not every number is in the form of what? Your kind of like this. If I just put a square root 4, you should be getting a positive or a negative 2. So this can be it, but we can also have a negative 4 there, right? So there cannot be any number which always be a natural number, because on a number line you will be having integers also. So you cannot represent any number in the form of square root m if that number is a natural number. Given, if you guys just look at your number line, you have this -1, -2, -3. So these are what? These are your negative integers. Those are not your natural numbers, although integers include natural numbers. But for this case, you guys see we have a negative value here. This cannot be happening. So remember this, there cannot be any point on number line which will be in the form of square root m, because there are not only natural numbers on number line, there are your integers also. So this should be false. I guess That was the difference here. I think I might have read this wrong. So this will be it from the earlier. Now let's see what we have now in our today's lecture. So we are going to shift towards our irrational numbers and their decimal expansions. If you guys remember in our earlier session, that means yesterday, I had just given you a hint regarding the decimal expansion of your square root 2. You guys remember this? We had just long divided this and I had told you that this will not be terminating at any given point and there weren't any decimal values, or you can say your digits, which were repeating in decimals, right? If you want to figure this one out, just divide this using your long division method, find out the square root of this one. So you guys see we have just only a lone pair, so 1 1, that will be 1 here. I will be having a 1, I will be taking a decimal, that will be 100. So you guys see I have to multiply this with 2 or I have to double this one, so that will be what, a 2. Then I have to think of a number, I have to multiply this whole number with that digit. Ultimately I should be getting a value that is either equal to 100 or it is less than 100. So I could think of 24, because 24 times 4 is what, it is 96. So I get what, I get a 4 and 100 here. So again I have to double this one, so that should be what, that will be 28. Now I have to think of a number, again multiplying with that same digit, the whole number gives me a value which is either 400 or it is less than 400. Now guys see, only number that I can think of is 1, because if I multiply that with 2, approximately I have 280 here, and if I multiply that with 2, I should be getting a 560, which is more than 400. So there is no chance of even thinking of a 2 here. So remember this, I should be taking only 1 here. That will be what, a 281, that will be a 9 here, and this will be what, a 1, and that will be a 1. Again we will be having a 2 zeros here, because we are finding out square roots using long division. So with every place shift in the decimal, you will be getting 2 zeros in your remainder as their in their unit or tens places. Now you guys see I have to double this one also, so that should be what, 282. Now I have to think of a number which will either be this one or it will be more than that. Now you guys see I have 282, just think of a number 2820, multiply that with 4. You will be getting a 0, that will be an 8, that will be a 32, that will be a 3 here, and that will be what, a 11280, right? Now let's just think if I had something like this. Now you guys keep in mind, I have just assumed this one 0, I haven't taken this as 4. So you guys see if I had taken that 4, that should be something different here. So let's just see if I had 2820 and I had multiplied this with 5. Just assume these two and multiply that, you will be getting what, a 140 something. So you guys see your answer is greater than your remainder, so that wouldn't be the case. I will be having a 4 here, or let's just say it is a 4, so I will be solving this one. So you guys see the answer is not even terminating, it will be changing its value later on. You guys see if you can solve this one, this will not terminate. That means it will neither repeat itself nor it will be terminating itself. If you want to verify this one, you can just divide this on your own. You guys will be knowing this will not be terminating or repeating. So decimal expansion of any irrational number, it is what, it is non-terminating and non-repeating. And you guys see, if I have a decimal expansion which is non-terminating but it is non-repeating, then I cannot represent that value in the form of p by q, because in order to represent a value in the form of p by q, let's just assume I had been given some decimal expansions and they had asked me, or they had asked you to represent that value in your form of p by q. That means they wanted you to convert that value in your rational numbers. So you guys have to firstly verify whether that decimal expansion is terminating or not. If it is having just finite digits in decimal, that will be the terminating expansion, then you can easily find that one out. If that is not the case, then you will be finding out whether the decimal expansion is non-terminating. If it is, then you have to verify whether that is repeating. It has to be repeating. Like you guys remember 0.333, which is what? It is actually 1 by 3, right? So you guys see this is a non-terminating decimal expansion, but it is a repeating one. So you guys see you can easily represent that into the form of p by q. But while you are doing this, while you have something which is non-repeating, remember that that cannot be represented in the form of p by q. So ultimately a picture should be in your mind that that number has to be what? An irrational number. So keep in mind, irrational numbers have non-terminating and non-repeating decimal expansion. I'm again repeating, non-terminating and non-repeating. So that will be the major thing that I want you guys to understand here, because everything that we do from now on regarding this exercise, that means your exercise 1.3, I guess, everything will be based on this one. So you have to just figure this one out and you have to remember that every time. So let's just move forward with this. So this is the major question that is mostly asked in exams, that 22/7 is a rational number but pi is not. Have you ever wondered what is the actual value of your pi? You guys should be remembering that. You guys should be hearing something in news that somebody has calculated the value of pi to its 1000th decimal value, even millionth decimal value. You guys see, if that is the case, if pi is actually 22/7, how are they able to find out so many decimal places for the value of pi and none of the places repeating itself? That means none of the digit is repeating itself. Now you can look at this picture here. I have this. The value of pi is what? There are some values here: 3.141592653589793238462643383233, and you guys see none of the two values, or you can say none of the values, are repeating after any given interval. That means after any given interval you have a totally new different digit there. You guys see 1415, then you have 92, 65, then you have 35, 89, then you have 79. You guys see value is not repeating and that is not also terminating. So if this is the case, if pi truly is this one and if pi is irrational, then how come this would be a rational? How could you represent a value which is non-terminating and non-repeating in the form of p/q? Right? I've already told you that none of the values which are non-terminating and non-repeating decimal expansions can be represented in the form of p/q. So why is this the value? It is generally what you guys should be remembering this from your mensuration portion. If you guys remember your area and parameter, specifically area of circles, in your earlier classes somebody would have told you pi is actually the ratio between your circumference and your diameter. It is not truly 22/7. It is actually the ratio between your circumference and diameter. Henceforth, none of the two values can be constant. Your circumference can increase, your diameter can increase, and even both of the values can decrease. So that is not a finite ratio. It can alter. So henceforth, you get an idea that pi cannot be a fixed value. So in short, this 22/7 is not actually the value of pi. It is not the value of pi. It is just a value that has been taken in order to make sure that your values are what? Your values are actually easy to calculate. Like if you want to calculate what? Your let's say if you want to find out your area and parameter and everything like that, you guys should understand this. If we had taken this value, keeping in mind this value is not fixed, it is just actually the correct name of this decimal expansion is infinite decimal expansion. You can say infinite decimals. So if there has been written what is actually an infinite decimal, then you should be telling that it can be a pi. So pi has an infinite decimal expansion because it is not finite, it cannot be repeating itself. So if you want to calculate or find out the area of circle or parameter of circle or any curved surface, like we are going to understand with our later videos in our chapter 13 also, you guys see if I had assumed this value, then I wouldn't be getting any answer because that value is not fixed for itself. How could my answer be fixed? So in order to make calculations easier, we chose to believe that the value of pi is 22/7 because it is roughly near to that. You can just verify this one. You can just solve your 22/7, divide 22 with 7. You will be getting a value which is actually repeating, but it is non-terminating, but that will be similar to its first 5 or 6 digits. So henceforth, we chose to believe that the values are actually repeating, although in exact value pi is an irrational number. It does not have a repeating decimal expansion. So I hope you guys can understand this and you are not having any doubt with this concept. So remember this question will be asked in your exam, so you have to keep in mind pi is irrational, 22/7 is the assumed value that we assumed for ourselves, so that we guys are able to find out areas. So I hope you don't have any doubt here, right? So let's just move forward with this And now we have the concept of finding out irrational numbers between rational numbers. So before this, just remember that your irrational numbers have which kind of decimal expansion? You guys should be telling me in the comments. It is what? It is a non-terminating and non-repeating expansion, right? So you have to do what? There are various methods. You can just do this like this also. If you want to find out irrational numbers between this, you have to do what? Multiply AB and square root that. That means multiply these two and put a square root over it. That will be an irrational between the given rationals. That means I can do it like this. 5 into 9 over 7 into 11, square root over both. So you will be having what? You guys see that will be what? A 45 over 77 and a square root. So that can be your one rational irrational number, or you can do what? I have a simpler method for you guys. Just do what? Pick your both rational numbers. Pick this one and pick that one. Firstly, find out after which place the decimals are repeating themselves. Since remember this is a rational number, it can have either two kinds of decimal expansions. It will be either your repeating, your terminating decimal expansion or non-terminating. If it is non-terminating, then it will be repeating. So these numbers will be having two kind of decimal expansions. So you have to find out which one of those is actually here. So I have 5 by 7. Just do nothing, divide this. 5 and 7, take a decimal, that will be 50. 7 sevens are 49. You will be having a 1 and a 0. 7 ones are 7. You will be having a 3 and a 0. 7 fours are 28. You will be having a 2 and a 0. That will be what? You will be having a 2. That will be 16. Sorry, 14. You will be having what? A 60. Then you will be having what? 8. That will be what? A 56. A 40. Then you will be having what? Again a 5. That will be what? 35. So you guys see, you are again with what? A 5. After subtracting this, that will be 50. So you guys see, you have 5 by 7. It is what? It is actually 0.714285. But after this fifth, that means after this 5, your 7 will be here, 1 will be here, 2 will be here, 8 will be here, and again 5 will be here. So you guys see, each of the numbers will be repeating themselves after this fifth position. After this sixth position. Now you guys see, if I just pick this one, I have 9 by 11. If you solve this similarly, you will be having 0.81818181. So you guys see, you guys can look at this. Your starting value is this and your ending value is this. That means 0.81 bar. So you have to find out any for irrationals between the rationals, right? Just do what? Actually write these 6 digits as they are. 0.714285. Let me just erase this and write it neatly. So do what? Just write these 6 as they are, 714285. Then you have to make irrational numbers, right? So remember this, irrational numbers have non-terminating and non-repeating decimal expansions, right? So do this 01, 001, 0001 and so on, because you can see the pattern here. 01, twice of 01, thrice of 01, then it will be 4 times 01, 5 times 01. So you guys see, this will be an irrational decimal expansion. You guys see, we have to find out between this limit, right? You guys see, it will be more here, right? The value will be more here, right? And it will be less than equal to here, right? That will be the case here. So you guys see, these two cannot be included. So I will be having a value which should be greater than this one. So you can see this value is greater. Obviously, you can see that is greater. And you guys see, our final limit is 0.81 and this value is surely less than your 0.81. So you can write as many irrationals as you want, right? So I can write one more here, 7, keeping this one same, 714285. Now here I chose to have this 02, 002, 003, sorry, or you can write 003 also, none of that matters, because the values are not repeating themselves. They cannot be having the same repetition. They can repeat after some different interval. You guys see, 02, 002, 003, or you can say have this one, 0004. So whatever you want to have, you can have that one, provided the value that you are writing is not having a particular repeating decimal expansion. So this will be it. I hope you guys have understood this and you don't have any doubt in this, right? Now let's just move on with this. Similarly, you can easily do this one. This will be 0.3 bar and you can easily solve that one. You can find out as many irrational numbers as you want in between these two. So I hope you don't have any doubt in this, right? So do this on your own, write that down in your notebooks. Yeah, that should be your homework. So let's just move forward. And now we have the concept of representing the real numbers on number line. We have to represent real or number line. So you guys already remember we had understood how to represent rationals on number line. Now we are going to understand if the rationals are in the form of p by q, that would have been easier. Now you have two choices here. Either you can represent your terminating decimal expansions on number line, like if I want to represent 0.2 on number line, that will be easy, right? This will be 0, that will be, let's say, 1. This will be what? A 0.1, a 0.2, a 0.3, 0.4, 0.5, and so on. That will be 0.9, and ultimately it will be 1.0. So you have to represent this. Your terminating values will be easier to represent. Just you have to look for what? You have to look for its ones place. You guys see it is 0 and it is more than 0, right? But it is less than what? It is less than 1. So it will be lying in the limit of 0 and 1, obviously. If I want to have something like this 0.23 and 1, 2, let's say that is the case, you guys see initially I will be just focusing on this value here, this one, that is 0.2. It will be lying between 0 and 1. I will be finding that one out. Then I will be having a 0.23. Then I will be jumping towards this one. Let's see how we are going to do this. So if I erase this, I have this one 0.2312. Okay. Firstly, do what? Just focus on your initial place. That means 1 by 10th place. So this will be lying between your 0 and 1. So let's say this is my 0. This is 1. This is what? A 0.1, a 0.2, a 0.3, a 0.4, and so on 0.9. So now you guys see I have 0.2. I have found that one out, but that is not the value. I have 0.23 here. So that means our value will be lying between these two. That means our 0.23 will be here. So I will be expanding this one now. So I will be zooming in on this limit. So I will be having a 0.2 here and I will be having a 0.3 here. Now guys see I have to look for 0.21, 0.22, 0.23, 0.24, and so on 0.29, right? Now I can see 0.23 here, which is here, but I need to have 0.231. So I have to look for this. So that will be what? That will be here between these two. So I will be doing what? Again expanding that one. I will be expanding this. That will be my new number line, which will be what? It will be 0.23 here and 0.24 here. Now guys see that will be 0.231, that will be 0.232, that will be 0.233, and so on, that will be 0.239. Now I can see 0.231, but I need to have 0.232. So that means my final value, what is my actual value, should be lying here between these two. So ultimately, zooming in on this one, I will be having what? My last number line, which will be what? 0.231, that will be 0.232, and ultimately 0.231, that will be what? 0.2311, 0.2312, 0.2313, and so on 0.2319. So you guys see, after this you will be having this one. So you have to look for 0.2312, and this is your value. So we have found the value here. So this is how you are going to represent the real numbers or number line when they are given you, when they are given to you what? When they are given to you in the form of the decimal expansions. So that was the case of a terminating decimal expansion. If that had been the case of non-terminating, then they would have mentioned to you that you have to find out the number correct up till 4 decimal places or 3 decimal places. That means if let's say I had this case 0.32 bar. So if I have to represent this on number line, initially if I write this, this will be this. It will not be terminating anywhere. So that means they will be giving you the condition that up till which decimal place you have to represent that. They most probably will be asking you to represent up till 4th decimal place. That means up till here. So this will be the case. You have to look for 3232. That can easily be done using this method. So I hope you can easily solve that one also. I have one more question here which will be based on this concept. I will be doing that for you, but if you are able to do that, so just note the sum down and try to do this one on your own in your notebooks. That will be your homework again, right? So let's see. If I just jump to my examples here, this is the question. Visualize the representation of 5.37 bar on the number line up to 5 decimal places. Now here what I was telling you, they have mentioned to you that you have to find out up till 5 decimal places. That means they want you guys to find out the number which will be 5.37777. That means quad 7. So you guys see how we are going to look for this one. Firstly, you have to look for your ones place. It is what? It is 5. So the number is greater than 5, but it is less than what? 6. So initially it will be what? It will be between 5 and 6. So you have to look here. So you guys see this will be what? A 5.1, that will be a 5.2, that will be a 5.3, that will be a 5.4, and so on, that will be a 5.9. Now we have to look for 5.3. I can easily see here it is 5.3, but I need to have 5.37. So that should be in between these two, right? The value is greater than 5.3, but it is less than 5.4. So I have to zoom in on these two values here. So my new number line will be what? It will be 5.3 here and 5.4 here. Now easily you can do this one. This will be what? A 5.31, 5.32, 5.33, and so on. Let's say this is 5.37, this is 5.38, this is 5.39. Now guys see, I can easily see 5.37, but I need to have 5.377. That means that value will be nowhere but here between these two. So I will again be zooming on this one. If I zoom on this one, I will be having what? That will be 5.37 here, that will be 5.38 here. So again 5.371, that will be 5.372, and let's say that is 5.377, and let's say this is 5.378, that is 5.379. Now guys see, I can see 5.377 here. I need to have 777, so that should be lying between these two. Similarly, once you have solved that one, that will be lying between 5.3777 and 5.3778. While you zoom on that one, ultimately you will be having 5.377777. So this is what you will be getting, and you guys see, you will be getting at this 5th place. See, 1, 2, 3, that will be 4, and this will be what? Your 5th place. So as many decimal places you have, you will be having as many your number lines, and on your last one you will be getting the value. So I had 5 decimal places here, so I will be having my final value in the 5th number line. So I hope you guys understand this and you don't have any doubt in this, right? So let's just move on with this, because that is quite easy. You guys can easily solve this one. So on the basis of this, you have your exercise 1.4. You have to visualize this one, which is very easy. You can easily solve this because this is the terminating decimal expansion. And you guys see, we have 3.765. This will be ending at your 3rd number line. So on your 3rd number line, you will be having this value, and initially that will be lying between what? You guys will be telling me in the comments. It will be lying between your 3 and your 4. Obviously you can solve this one, so that will be quite easier for you guys. I hope you don't have any doubt here, right? Now let's just follow this up and look at our second question. We have what? We have this one, 4.26 bar. You guys see, you have a bar over 26, so you guys can easily solve this one. You have to find this one up till 4 decimal places, so that should be what? 4.26 and 26. So you guys see, this will be quite easier for you guys. You have to do what? That will be lying between, since this is greater than 4 but less than 5, so it will be between 4 and 5, and you have 4 decimal places here. That can easily be your case. You can easily find out your value on your 4th number line. So I hope you guys have understood the case and you don't have any doubt in your exercise 1.4, which is very easy, right? Now with this, we are going to jump towards operations that we can perform on our real numbers. So you guys already remember, we can add 2 rationals, we can add subtract 2 rationals, like we can add 1 by 2 and 1 by 3, we can subtract 1 by 2 and 1 by 3, we can multiply 1 by 2 and 1 by 3, and even we can divide 1 by 2 and 1 by 3, right? We can do anything with the rational numbers. So now the question is, what can we do about our irrationals? Can we do the same things with our irrationals? So keep in mind, your irrationals are like your if you guys have understood your algebraic expressions, and if you guys remember your factorization from your earlier class, your linear equations also, irrational numbers act as your variables here. Let's say if I want you guys to understand this very easily so that you don't have any trouble in your mind, if I have 2 root 2 and I have to add this with 3 root 2, how can we do this? This is pretty easy. Just do what? Assume this 2 root 2 be x in your mind. That will be what? 2x, and that will be what? 3x. Now you guys can easily add these two. You will be having what? A 5x, and replace the value here. That will be what? 5 root 2. So as long as your irrational portion is same, you can add them or you can subtract them. But if you have two irrational numbers, let's say I have square root 2 and I have a square root 3 and I want to multiply them. Remember this, while you are multiplying two irrational numbers, the square root remains the same, but their bases are multiplied. That means 2 will be multiplied with 3. That will be what? That will be square root 6. Reason being, if you can recall your exponential powers from your earlier class, you guys remember this can be written like this, 2 raised to power 1 by 2, because actually square root is what? Square root is equal to 1 by 2 power. So that is what? That is 1 by 2, and it should be multiplied with 3 raised to power 1 by 2. Now guys remember, a raised to power m multiplied by b raised to power m. If the powers are same and the bases are in multiplication, so power will be substituted once, bases will be multiplied. So that is what I have done here. So in multiplication or division, it does not matter whether the irrational part is same or not. You can easily multiply two irrationals and you can easily divide two irrationals if the irrational portion is same. That means if I was multiplying square root 2 with square root 2, you guys see that will be giving you what? A 2, or you can say that will be giving you a square root 4, which is actually what? A 2, if you are following this method. So you can do anything with your real numbers, that means your rationals and irrationals, or any other number like your whole number, your whatever you have here earlier also. So you can apply any operation on any of the real numbers, everything will be valid here. So if this is the case, I have this. Before we get to the point of rationalizations, let's just understand what happens if I multiply two irrational numbers. Let's say I have this one, I have square root 2, and if I multiply that with square root 3, you guys see your answer will be what? A square root 6. If I add a square root 2 with the square root 3, you guys see irrational portions are not same, so your answer itself will be this one, square root 2 plus square root 3. Why is that? Just assume square root 2 be your x and square root 3 to be your y. So x plus y cannot be added together, so it will be x plus y, or you can say it will be this, right? Now if I just jump forward with this, and if I have this one, square root 2 minus 7, let's just not confuse here. Firstly, let's just assume I have an irrational number which is square root 2, I have another irrational number which is square root 7. If I subtract them, they won't be subtracting because they are not same, so that will be same. That will be square root 2 minus square root 7. So you guys see, if I multiply two irrational numbers, your number can be irrational or it can be rational also. How? If I multiply square root 2 with square root 2, you guys see I will be having what? I will be having, this will be what? A square root 4. That will be what? That will be a 2, which is 2 by 1 in the form of rational. So while you multiply two irrational numbers, your product can be a rational or can be an irrational. Remember this. Now while you are adding two irrational numbers, your number will be what? Your number will always be irrational. Why is that? You guys see here, if I add square root 2 and square root 2, I will be having what? 2 square root 2. Again you guys see I'm not getting rid of the square root here, so that will be what? That will be irrational. So while we are adding two irrational numbers, number will always be what? It will always be irrational. Now remember, if I have the case of irrational but we are subtracting them, what can happen here? Let's see, if you look at this, this is irrational, right? But if I have something like this, square root 2 minus square root 2, you guys see that will be giving you a 0, which is 0 by 1 in the form of t by q. So if you subtract two irrational numbers, your answer can be a rational or an irrational. So remember this, that will be the case here. Now if you are dividing two irrationals, what can happen there? Let's say if I have square root 2 divided by square root 3, so this will be what? A square root on whole, that will be 2 by 3. So you guys see that is irrational. But what happens if I have square root 2 divided by square root 2? You guys see that will be what? A 1, which is what? Rational. So when you divide two irrational numbers, your answer can be either a rational or an irrational. So only in addition your answer will always be irrational if you're adding irrationals. But in any other case, it can be a rational or it can be an irrational. Remember that? Understood this? Now let's see. If I just erase this one and if I focus on our next part, if I have rationals here, so you guys see, if I add 1 by 2 to root 3, you guys see this will not be terminating, that will be what? Irrational, because there is this case. And if I subtract 1 by 2 and root 3 or root 3 minus 1 by 2, your answer again will be irrational. If I multiply rational with irrational, that means 1 by 2 into root 3, your answer will be what? Root 3 by 2, again irrational. If I divide irrational with rational, that means root 3 divided by 2, again you guys see that will be what? Irrational. So any operation related to irrational and irrational, your answer will always be irrational. Now we are going to shift towards our concept of rationalization. So what is the need of rationalization here? Rationalization is necessary when you have to do what? When you have to get, always remember, while you are operating with your irrational numbers, you cannot leave your irrational as your denominator. Let's say after solving something, I end up getting this 1 by square root 2. That cannot be left like this. This is not a healthy practice. So you have to do what? You have to rationalize that. Now what is rationalization? You just have to make your denominator whole. So how you are going to do this? You just have to pick the irrational number. In our case, we have square root 2. Multiply that with the same square root 2. Divide that with the same square root 2. Now you will be having what? 1 into square root 2, that will be square root 2. Square root 2 into square root 2, that will be what? Square root 4. Ultimately, that will be what? A 2. So that value will be acceptable, and this is what? This is the rationalized value. So rationalization is done in order to make our denominators whole. So that is the whole point here. Now you guys see, in rationalization what we are going to do? We are going to pick out our irrational number, then we are going to multiply it with that number and divide with that number. Reason being, these two will cancel out and you are not affecting your answer directly, but you are just making the denominator whole. So that is the case here. Now what to do if I have something like this? 1 over square root 2 minus 1. So what you have to do here? Nothing, just pick this term. So pick the both values here. That means square root 2 and 1. Put it over denominator, square root 2 and 1. Whatever the sign is here, that means in our case it is negative, put its opposite sign here, positive and positive. Multiply that. If you multiply this, you will be having what? 1 into square root 2 plus 1, that will be square root 2 plus 1, and square root 2 minus 1 into square root 2 plus 1. You guys see, a minus b, a plus b, that will be what? A square minus b square. Remember this, any identity will be applicable on your irrational numbers, because I have just told you that they act as your variables. So you can see x minus 1, x plus 1, this is an identity which will be what? X square minus 1. So obviously it will be what? Square root 2 whole square minus 1. So it should be what? Square root 2 plus 1 divided by 2 minus 1, that will be what? Square root 2 plus 1. Answer. So if you want to rationalize this one, first you have to keep in mind, if you have more than one term in your denominator and one of those is your irrational, another can or cannot be irrational, then you have to write both of the terms in your numerator and denominator separately, and you have to take the opposite sign there. Reason being, we will be using this identity and only then we can get rid of our irrational portion, because squares always remove your square roots. That is the whole point of this method here. I hope you don't have any doubt in this, right? So that is the case of rationalization. You can rationalize any value here, even you can rationalize this one also. 1 over square root 2 minus square root 3. You have to do what? Just multiply this with what? A square root 2, square root 3, positive sign here. Square root 2, square root 3, positive sign here. Just solve them, you will be getting the value. So I hope you guys have understood the concept of rational number, because that is very easy, but that is very important also. Now on the basis of this, I have this worksheet for you guys. You can easily do this. I will be doing this question for you guys. Everything else will be your homework. We have what? 3 plus root 7 over root 5 minus root 3. Now you guys see, we won't be touching this numerator, although we will be doing something with this denominator, because we have to rationalize only denominators. But there is no limitation that you cannot rationalize numerator also. You can similarly rationalize numerator also, but there is no point of rationalizing that. So we always rationalize denominators. So I will be multiplying this with what? A square root 5, a square root 3 divided by square root 5, square root 3 Negative sign is here, so I will be putting a positive sign, Then you have to do what? 3 plus root 7 multiplied by root 5 plus root 3 over, this will be what? A minus b, a plus b, a square minus b square. Now you guys can easily solve this one. Even assume your root 7 to be x and root 3 to be y, or you can do what? Just pick this bracket, expand that one. 3 here, root 7 here, put the other bracket here, root 5 plus root 3 and root 5 plus root 3, that is root 7 here, sorry. And in a denominator, we will be having what? A square root 5, its whole square, that will be what? A 5. Square root 3, its whole square, that will be what? A 3. Subtracting that. Now guys see, 3 into root 5, because this is rational, this is irrational, they won't be multiplying easily, so that should be what? 3 root 5. 3 into root 3, that will be positive 3 root 3. Root 7 into root 5. Now you guys see, both of them are in root. 7 and 5 will multiply. You will be having a root 35. And root 7 into root 3, that will be what? Root 21 divided by what? Divided by a 2. So that will be what? That will be your answer. So this is how you are going to rationalize your values, and everything else is pretty straightforward. You can easily solve these sums along with your NCERT questions. I hope you don't have any doubt in this, right? So this is how you are going to rationalize this. Now let's see what do we have now. So these are some examples for you guys. You guys see, you have this one, a plus b, and you have this. Simply just expand the brackets. 5 into 2 plus root 5 plus root 7 into 2 plus root 5. Now you guys can easily multiply this with that and this with that, and ultimately you will be having the value. You guys see, this is what? A plus b and a minus b. This will be a square minus b square. So 25 minus 5, that will be what? 20. Given square of 5 is 25, square of square root 2 is 5. So that will be what? That will be 20, right? You have this a plus b whole square. You guys remember that identity, right? A plus b whole square, that is what? Repeat after me. A square plus b square plus 2ab, right? So you can easily substitute the value here and you will be getting the answer. Again, this one is what? A minus b, a plus b, a square minus b square. So 11 minus 7, that will be 4. So I hope you guys are able to solve these, right? So that will be the question here. These are some examples, you can easily solve them. Now this is the last portion of this video, and this will be the last portion of your chapter also, because we are just towards the end. The reason why I'm pushing this one, because all these 3 topics had not much to offer. They were pretty straightforward, so I thought why not just put in one video so that you don't have to wait for another one. You can just focus on your practice exercises on our website also. So this will be it. Now let's see, we have what? We have laws of exponents here. Before we get to the point, just remember what are exponents. Exponents are these, your powers. This is what? See, if you have your base and you have some power here, this is what? This is your exponent, or you can say this is your surds. There is a bit difference here. Surds are just generally your irrational numbers. So there is one more term to represent your irrational numbers. Let's say square root a. That will be the case of surds. They will be incomplete square roots. Whereas your exponents can be your complete whole powers. Let's say 5 raised to power 3, 2 raised to power 3. Surds are basically the powers which are either in fraction, or actually if I tell you, they are not whole powers. The powers are not whole. That means they are not whole numbers. Like they will be, if I represent this, this will be what? A raised to power 1 by 2. Similarly, a raised to power 1 by 3, a raised to power 2 by 3. So these are what? These are your surds and these are your exponents. Now you guys can easily recall this concept from your earlier classes, because you have been learning your laws of exponents from like your 6th standard. So you guys should be able to recall everything. Just stay with me what we have here. So I have the law, let me just get to it. See, base and exponents here. So this is the question here. Let's just jump to the laws here now. So we have major laws which are like this. If I have any base a which has any power m, and it has to be multiplied with any base a and any power n, you guys see bases are same, then the powers will be what? Their powers will be adding. So it should be what? A raised to power m plus n. Reason being, if I have 2 raised to power 3, I have to multiply this with 2 raised to power 2. You guys see, it can be written like this: 2 into 2 into 2 and 2 into 2. These 2 here, these 3 2s here. So you guys see, we have 5 2s. That should be what? 2 raised to power 5. So in short, I could have written it like this, 3 plus 2, which will be 2 raised to power 5. Similarly, if I have any value which is a raised to power m, let me just erase this. So if I have any value which is a raised to power m, but that has to be divided with a raised to power n, then what happens here is powers are subtracted. You can just easily take the earlier example and you can verify this one on your own. So powers will be subtracting here. Now one more case, if I have any base but its power is 0, its answer will always be 1. That is the case here. Now if I have any value a, any base a whose power is m, that has to be multiplied with the b whose power is again m, then power will be same, bases will be multiplied. See, if I have 2 raised to power 3, I have to multiply this with 3 raised to power 3. You guys see, this will be 8, that will be what? That will be a 27. So multiply this, whatever you get, that will be actually what? That will be the multiplication of these two. So that means it can easily be written like this, 2 raised to power 3 whole cube, which will be what? A 216, and this will be what? Cube of 6. 6 is what? 2 raised to power 3. So in short, if you have the common powers, then the bases will multiply, power will be substituted only once. Now similarly, you can do it like this. If a raised to power m is there, then you have to divide that with a raised to power n. This will be what? A raised to power m divided by a raised to power, sorry, I have just taken this to be b. Actually this will be b raised to power m, because we have already understood this case. This will be b raised to power m. Then what happens here is, power will be written once, your bases will be divided. That means it will be a by b. Understood? So that will be the whole point here. And one more thing, just keep in mind, if you have power over power, that means a raised to power m whole power n, then these two powers will multiply. That means a raised to power m multiplied by n. That is the whole point here. Reason being, let's say if I have 2 raised to power 2 and whole power 2, that means 2 into 2, I have to write this one twice. So that will be what? 2 into 2 into 2, that will be what? 2 raised to power 4, or in short, just multiply these two. That will be whole point here. Now on the basis of this, we have some questions here. See, we have what? 4ab square minus 5ab cube divided by 10a square b square. It is very easy. You can do what? Just write it here. 4, you can write it like this, 2 into 2 into a into b square into minus 5 into a into b cube divided by 2 into 5 into a square into b square. Now guys, see, 2 into minus 5, that will be what? That will be 10. So they will be cancelling out. There will be a minus 1 here. So in short, your answer will be carrying a negative sign. Now guys, see, I have an a here, I have an a here. Powers are same, they are in multiplication. That will be a square and a square will cancel out. Again, I have b square, I have b square. They will cancel out. So my final answer will be what? A 2 and a b cube. So this will be what? 2b cube. Or if you want to do it exactly, this will be what? A and a, this will be a 1 plus 1. That will be what? A square. I have to divide this with a square. You guys see, bases are same, power they are in division. So you will be doing what? 2 minus 2, that will be what? A raised to power 0. This will be what? A 1. So reason being this. So I hope you guys have understood this question, right? Because that is the portion of your class 8 or 7. So you can easily solve this one verbally. Now one more question here. You have to find out the value of a raised to power b and b raised to power a. You can easily solve this one. 3 raised to power minus 2 plus 2 raised to power minus 2 raised to power 3. And I think I haven't told you this, but a raised to power minus m is what? It is 1 over a m. This is what? This is inverse power. So if I have 3 raised to power negative 2, that will be what? 1 upon 3 whole square. And if I have this one, this will be easily solved. This will be minus 8. You can solve this one and get the answers here. This was just one thing I think I haven't written earlier. So this is another rule here. If you have any base whose power is negative, you can make its power positive by just putting it in the inverse. That means in the denominator of 1. So that will be what? A raised to power m here. So this will be easy. You guys can easily solve this. Similarly, you can easily solve this one. Note this down in your notebook. That will be your homework. This question is very easy. I want you guys to do this also. I will be doing it for you. See, you guys have this one, 1 over 1 plus x a minus b. Just focus on this a minus b. You guys see, bases same, powers are subtracting. If you guys remember, a raised to power m minus n, it was when am was divided by an. So can I write in this place x raised to power a divided by x raised to power b? So easily I can do it. So 1 over 1 plus x raised to power a divided by x raised to power b. Similarly, 1 over 1 plus x raised to power b divided by x raised to power a. Take LCM, that will be what? 1 over xb plus xa plus, take LCM again, 1 over xa plus xb, right? Because there is nothing here. So LCM will be xb. You can easily solve this. This is the whole denominator. It will be numerator. This will again be numerator. So you have what? You have this x raised to power b over x raised to power a plus x raised to power b, and x raised to power a over x raised to power a x raised to power b. Now guys, see, base is same, denominator is same. You can just take LCM again. X raised to power a plus x raised to power b, x raised to power b plus x raised to power a. They will cancel out, and ultimately it will be what? It will be 1. And you had to prove this one, and ultimately we have proved this. Very easy question. This can be asked in your exams also, so you can just keep in mind. This is how you're going to attempt various questions. On our website, we have various questions related on this concept. You can just log on to that and you can just try as many questions as you want, and you can just bring your doubts to me. I will be happy to clear your doubts also. So this will be the case here, and this will again be easy for you guys. There is nothing different about this. You can easily solve this one. And this is your exercise here. You guys see, we have 64 raised to power 1 by 2. Now guys, remember, 64 raised to power 1 by 2. How are you going to do this one? This means you have a square root here. That means square root of 64. That will be what? That will be 8. Now here you have 32 raised to power 1 by 5. Remember this, while you have the powers in your fractions, always remember you have to prime factorize your base. Then you have to put the brackets, or you have to group the prime factors into the number of denominator here. Let's say I have denominator 5 here. So I will be doing what? I will be prime factorizing my 32. This will be what? 2, 16, 2, 8, 2, 4, 2, 2, and 2, 1. You guys see, you have to group these prime factors into a group of 5 each. So that means all these 5 2's will become one group, and out of that group you have to take as many numbers as your numerator common. Now guys, see, I have just 1 here, so I will be picking only 2 here. That will be what? Our answer. But there is one more way around to it. You guys see, 32, I can write 32 like this, 2 raised to power 5 and its whole power 1 by 5. You guys see, powers and powers, they will be multiplying. This will be what? 2 raised to power 5 into 1 by 5. This will cancel out and you will be having what? A 2 raised to power 1. Right? So similar answer. Similarly, you can do this one. Now in this case, you have what? Let's see. We have this one. 9 raised to power 3 by 2. Just do it bit by bit. Can you write 9 like this? 3 raised to power 2 and whole power 3 by 2. Right? Power over power, power will multiply. That means 3 raised to power 2 into 3 by 2. Just cancel this one out. You will be having a 3 raised to power 3. That will be 27. Similarly, you can do this one, you can do this one, and you can even do this one. But before you attempt this, just make the power positive, or that does not matter. You can even do this later on. See, I have 125 whole power 1 by 3, negative 1 by 3. So can I write 125 like this? 5 cube whole power negative 1 by 3. This will cancel out. I have what? It will be 5, and that will be minus 1 here, right? So guys, see, 5 inverse, that can be written like this, 1 over 5. So these are some questions which are very easy. You can attempt that on your own. So try to do each and every part on your own and bring your doubts tomorrow. I will be happy to clear your doubts. But for now, this will be it. And to wrap this chapter up, we have done what? We have understood our number system completely. But our naturals, these are the numbers which begin with 1 and end up till infinity. Then we had whole, which were beginning with what? Your 0, ending up to so on infinity. Then we had what? Our integers, which were either negative or had a 0 or were positive, lying between this limit. That means negative infinity to positive infinity, including 0. Then we had what? Our rational numbers, which were represented in the form of p by q, where q was not 0. We had our irrationals. What were those? Which could not be represented in the form of P by Q, basically your certs. Then we understood how to represent irrationals or number line. Then we understood the decimal expansion of your rationals and irrationals. So rationals had decimal expansion which was either terminating or non-terminating but repeating. While in the case of irrationals, we had the decimal expansion which was non-terminating and non-repeating, right? Then we represented irrational or number line. Then we found out irrationals between two rationals, right? We have done that also. And then we understood the concept of rationalization, in which we did what? We rationalized our denominator, like we had this one 1 over square root 3 multiplying with square root 3 dividing with square root 3. So we had what? Square root 3 over 3. That was the concept of rationalization, right? And lastly, we understood the concept of what? Understood the concept of our indices and certs, or you can say your exponents and powers. We have done that and we have completed this entire chapter now. So now work is on you. You have to attempt this chapter once more on your own. Pick up firstly your NCERT, attempt each and every question. If you have any doubt in those, you can just ask me in another live class. I will be happy to clear your doubts. Or you can do what? Firstly finish that, then come to the website, attempt as many questions from our question bank. You will be practicing as much as you want because we have tons of sums for you guys. You can attempt them. And keeping that in mind, I have a news for you guys. From this coming week, that means from next week, we are totally shifting towards our application based services. So you guys will be having a live classes on our application. So I want you guys to subscribe to that application so that you don't miss anything. I will be there. You will be having various new features there. You will be having some benefits of the application, like you can just ask me questions during my live class. You can even request the calls to me. I will be happy to clear your doubts. So I will be there. I want you guys to just join that. So download our application from our website. The link is there. So see you in the next live class. Till then, remember this. This is the final video for your chapter 1. We will be having more videos and you have to practice each and everything. Bye for now. This will be it. I'll see you in our app. So see you on our app. Till then, bye. Practice as much as